Good afternoon. This is Ananya, and today is the last class, the extra class for the Fundamentals of Additive Manufacturing course. This is gonna be a recapitulation class for all the variant and classification of additive manufacturing that has been covered. So I have a PPT ready for today where I have put all the classification of additive manufacturing, and you can find out the seven various types of additive manufacturing that has been covered in last 12 weeks. If you have any specific doubt on these 12 or any of the processes, then you can let me know. Also, for classification, the ASTM standard, or according to the ASTM standard, we have seven classifications. So these seven processes are called the state of the art. Under this seven state of the art, we have various processes as well. For example, there is one state of the art called directed energy deposition. But under this state of the art, we have different processes like WAM, where are additive manufacturing, powder DD, wire DD, then laser DD, plasma DD, RDD, wire and powder DD, both mixed together, hybrid DD. So these are variant processes under the state of the art of DD, directed energy deposition. Like that, for other six categories also, we have different processes. So I have a PPT for that. I have a Mentimeter, very interesting questions I have prepared for this class, so that if you have joined, you can answer. If somebody is watching this video later on, they can also participate in the quiz and answer and just have a recap on all the processes and some more detail on each processes. I have put on in those questions. So let me share my screen. I think it's visible. So according to ASTM standard, we have the seven category called material extrusion, sheet lamination, binder jetting, vat photopolymerization, directed energy deposition, material jetting, and powder bed fusion. In these, the material extrusion, the some part of directed energy deposition uses the wire form of material. In binder jetting, but in again some portion of directed energy deposition and powder bed fusion uses powder as a raw material. Sheet lamination uses the raw material in sheet form. Vat photopolymerization and material jetting uses liquid form of raw material. In some of this process, in this classification, some of the processes are capable of printing metal parts, but all of them are not capable of printing metal parts. Some of them are capable of printing polymers. Some of them are capable of printing both metal and polymers. Some of them are used for ceramics also, like sand, mold, printing, and everything. And one of the process, like sheet lamination, works with paper, wood, and metal all. So in all the seven processes, I would like to point out few very important points. So material jetting can give us the highest resolution parts for polymer printing. So material jetting can print only polymer, and it can give us the highest resolution part. The resolution of the part and the minimum feature size possible, like if you're printing something very complex, if you're printing something with internal structures or some kind of intrinsic parts, features with higher accuracy and resolution, you can print it using material jetting. But the only issue is it can only print the polymer, and it uses the liquid form of polymer. In case of other processes, like vat photopolymerization also works with polymer, and it also produces a very high surface finish parts. On the other hand, if I talk about the metal, Then powder bed fusion can produce the highest resolution metal parts with minimum feature size possible, with the highest level of accuracy, most complex structures and everything. One another most important point, among all the processes we know in additive manufacturing or 3D printing, there are two things called part and support. So there is one thing called support structure. Support structures are used to support, to give or provide the mechanical support to the overhang features in your printed parts. It also helps to dissipate the heat that is being produced in the process. Now, why heat is produced? So, additive manufacturing is a layer by layer material deposition process where you can print any complex shape or geometry directly from the CAD model of it, in which the material will be present in its raw form, like either powder or liquid or sheet or wire. The energy source will directly interact with this raw material. The energy source can be coil, like induction based heating, resistance based heating, or laser or plasma, high energy plasma laser, electron beam, or arc, or even the UV light. These energy sources directly interact with the metal powder and with the material. Raw material can be anything, and they get the material to be melted and solidified. I think you are unmuted, Abhi. Okay. So this energy source can directly interact with the raw material, and you can get the final shape and geometry. So the support structure is needed to dissipate this heat that is being generated because of this energy source and to provide the mechanical support. But in all of the among all the processes, binder jetting is the only one process where you actually do not need any support structures. Other than binder jetting, we have another process called sheet lamination. This also can produce parts without support structure because it's a layer by layer process. And in case of binder jetting, we have powder bed. So in the powder bed, the loose powder particles itself act as a support material for the process. Similarly, for sheet lamination, the sheet of the paperboard or metal, whatever you are using, itself works or acts as a support structure for the printed part. Let's now jump into one another processes to get an overview and the recapitulation. So first, can you guess what process it is? This written names are in different languages, and purposefully I have put this photo to see if you can guess the process by just seeing the overview picture. Can anybody guess which process it is? Any guesses? Pardeep or Abhi? No? So you can
Wire,
see. Yes. Yes.
polymer wire.
Yes, polymer wire. So there's the process involves the polymer wire, then how it prints. So the name of the process, can you remember? So okay.
So
So
sorry, I
this
can't
yeah.
remember.
Okay, no problem. So this process uses the polymer wire. We can see there are these pulleys which are maintaining the tension between the wire and pushing downwards. Then it is passing through this nozzle. This orange color is the nozzle. It's passing through the nozzle where resistance heating or induction heating is present, like coil based heating basically. and then they are getting melted and deposited over the build plate. This is my build plate. This build plate is mounted like this. Ash color is the build plate, which is mounted on a CNC, which can go down or up. Then this is my part. This blue color is the support structure for it, and yellow is the part. So this process called fused deposition modeling, FDM, which comes under the state of the art of material extrusion. So here we can print polymer or metal both at different machines. For polymer, we use the induction heating, but for metal, we use resistance heating. It's just like for metal, you need more energy. So that's why. And the raw material doesn't get fully melted, but it's kind of a semi-melted form. Like you can take an example of toothpaste. So it will come out from the nozzle like the toothpaste, and it will be deposited on the build plate layer by layer, and the whole system will be mounted on a CNC, computerized numerical control, where you can put some code, G code, M code, and according to that, your tool and the build plate will move in XYZ direction. If your CNC is having only 3 degrees of freedom, like it can move in X, Y, and Z only, then you have to have support structures to provide the mechanical support for the overhang features. But if your machine can move more than XYZ, like it can have tilt axis, rotation axis, more than 3 degrees of freedom, then you can approach for the support free printing, where it's like if your part needs the support structure, at that moment you can tilt this build plate and the nozzle will come here to print this part, so that your support structure is not needed, because this part looks like this. So my part looks like this. So I need a support structure in this portion. So if my tool can come like this to print the material, then I don't need the support structure in this region. So that means my build plate has to have more than 3 degrees of freedom. So let's go to the next process. My next process is, any guesses? Here what is happening? So here I can see the liquid resin. I can see a projector from which the lens is placed. So obviously a light source is coming. And here it's written UV light. So basically the UV light is coming from the projector, passing through the lenses, getting diverted using a bending mirror, and then it's getting projected over the build plate. So it's the wet photopolymerization process, where the liquid resin is the raw material. So the resin is a kind of polymer. So in this process, you can only print polymers. The polymer has to be in liquid form. Mostly the resins are getting printed in using this process. So we use thermosetting type of polymer. Now the build plate moves up by each layer thickness. This vat or the container is full of liquid resin. When it touches the ground, it has only one layer of liquid resin present beneath the build plate. The UV light comes and cures the resin. It's a photopolymerization reaction. That means there are monomers of the liquid resin present, and the monomers are getting photopolymerized to get the final geometry. Next, we have the same category, VAT photopolymerization, but we call it as a stereolithography, SLA. Here, the laser is coming instead of UV. It's not about laser or UV, it's about the wavelength. So there, the UV light was having some wavelength which is lower than 400. But here, the laser is having, it can have 400, more than 400, or less than 400. If it's less than 400, we will call it as a UV laser. So the laser is coming. It's similarly a light source. It's curing the liquid resin, which is present here. You can see this is the bill plate, and the bill plate is as it's mounted vertically upside down. So my model is getting vertically upside down printed. But when you इसको सीधा करेंगे हम, when you move, take out the bill plate, your model will be ready in its original direction only. So this is called stereolithography, SLA, which is again coming under the state of the art of VAT photopolymerization. Next, we have material jetting, where we can only print polymer. We can only have the polymer in the liquid form. So you can see here, we have two containers of liquid polymer. One is the build material, one is the support material. Both the things are coming. Here are two nozzles. Two nozzles are here. You can see through these two nozzles, the material is coming out and getting printed. It's a simple process, as you can see here. So this is my nozzle 1, this is my nozzle 2, this is the support material S, this is the build material B. This droplet by droplet, the liquid polymer is coming, getting deposited. At the same time, a UV light source is also coming to quickly cure the liquid droplet. Because if you are going to fall the liquid droplet on top of the bill plate, your bill plate will have the liquid which will get cured but will take time. So to make the process faster, we are also providing UV light from the same CNC holder or CNC head to quickly cure the liquid droplet which is coming from the nozzle getting deposited on the bill plate. Next, we have this process which is called the binder jetting. So it's similar kind of process like which uses polymer, but it and also use metal, where this powder is kept in a container, and this roller, this is joined. Okay, this is not a separate place. These two containers are joined together. This roller has the powder which it will spread on top of the bill plate, and then this liquid, this head which can move in X and Y direction, it is having some ink which is nothing but a glue like binder which is coming. So the powders are spread on top of the bill plate. The binder is coming. So basically the glue is coming. Glue is falling over the bill plate on the powder wherever it needs to be joined. It needs to print the part, and layer by layer this process is happening, and we are basically gluing the powder together. If you remember from the childhood crafts classes, we used to put glue and then we used to put the glitter on it and then just blow out all the glitter, and you'll have the perfect shaped glitter you have printed or you have drawn over a picture in the paper. Similar case, just the opposite process. First, we are putting the powder, then we are putting the glue, and layer by layer, we are doing the same process. We are repetitively putting one layer of powder, glue, put the glue on it, then again putting one layer of powder, putting the glue. And like that, when the part is completed, we are just blowing away the powder, we get the final part. This part will have a very less strength, so we often go for post-sintering or heat treatment processes to get a better strength for this part, because here we are not melting any powder particle, but we are kind of gluing them together. So there can be porosity, there can be other problems, voids and everything. So to get the strength out of the real powder, we go for the post-processing. This is the sheet lamination process, where the sheet is kept in this roller. This roller, from the roller, the sheet is coming. There is a, you can see there is a laser. This laser is actually cutting the sheet in a proper format. So this is the only process where we do hybrid kind of manufacturing, where we subtract, like cut, and also join. So in additive manufacturing, it's well known for joining. Like we do the additive part. We don't do subtractive manufacturing here. But in this sheet lamination process, we do subtractive first. So we cut the sheet of paper or wood in a appropriate format according to the shape and geometry of the part to be printed. And then this roller roll over the sheet, and it joins the two subsequent sheets, which is placed on the top of the bill plate. This is the bill plate, and this is the part already printed. It's like from the roller, the paper is coming. The paper is being cut using a laser or a knife. Simple knife can be also used. Then this roller roll over the paper sheets to press them together, join them together. Like that, this process works. This is also a process where you cannot use this excess raw material. So this excess raw material is going to be a waste. Additive manufacturing is again well known for waste management. Like the waste is very less in this process, but however, in this particular sheet lamination, the extra material that is going away and coming in this roller, that cannot be reused. Then this was the photo from the last process. Actually, it came here. This is the binder jetting nozzle from which these binders are coming. Binders means the glue for the binder jetting. The process where we put the powder on the bill plate and then the binder was coming. So this is the photo of the head from which the binder or the liquid is coming, and this is how it looks like. This is how the glue comes spread or put over the bill plate full of powder particles. Second last, we have the DED process, where here we can use arc, laser, plasma as an energy source. Here, laser is being used as an energy source, and wire powder both can be used as a raw material. DED is a process which can print only and only metal, no polymer or other material. This is only possible. This is only useful for metals. So metal powders are coming, laser is coming, directly interacting over the bill plate and depositing the material. This is the deposited bead, already deposited, and now it is depositing in this direction. This is called the cladding head, from which the laser and the powder all comes at the same time. This is again the second example of DED, directed energy deposition, where we are using the wire as a material. Here we were using powder as a material. Here wire is being used, and along with the wire, the electrical connection has been made, like cathode anode, and the arc has been established between the bill plate and the wire, so that out of this arc, high energized arc, high voltage arc, we can melt the wire and deposit over the bill plate. So this is called WAM, wire arc additive manufacturing. I don't know what is happening with this pointer. Wire arc additive manufacturing. Next, the last type of DED, which is the electron beam DED. So here, instead of laser, the electron beam is coming and the wire is fed from off axis. Similarly, the wire is getting melted using this high energized electron beam. Here it was getting melted using arc. Here it was getting melted using laser. Instead of powder, you can also using wire of metal, and you are depositing the metal. Only difference between these three are, for electron beam, you have to have a high vacuum chamber. As you are restricting the chamber as a high vacuum chamber, your chamber will be smaller than other processes, because creating vacuum is really costly, and it will add a lot of more components, so it's costly. So that's why we can create low volume parts. The last process is the powder bed fusion, where similarly like binder jetting, the powder is being spread using a recoater or a roller. The powder layer will be spread on top of the bill plate. The laser comes to melt and solidify the powder here. In case of binder jetting, the binder or the glue was coming to fuse the powder particles together. The powders were not getting melted. Here, the powders are getting melted and solidified. So there is a difference. Powder bed fusion can be used for polymer and metal both. It can have two processes under this. So you can have laser powder bed fusion, electron beam powder bed fusion. And under laser powder bed fusion, you can have SLS, selective laser sintering, where you don't melt the powder but sinter them together. Another is SLM, selective laser melting, where you melt the powders together and fuse them together to get the final shape and geometry. This is a photo where you can see this is the cladding head. From the central nozzle, the laser is coming, and from the circumferential nozzle, the powders will come. This is the head, how it looks like. And this is the process of material jetting, where from this, the UV light, we can see the light, the glowing light. Along with the light, the droplet of material is also coming and getting deposited over this. And this is the process of electron beam melting, which where I have shown this last class, like yesterday also. This is the process called preheating that we do to reduce the residual stress in the metal part to be printed. So that's all about my PPT and recap about all type of additive manufacturing. I'll upload this PPT in the drive. Now I have this question answering. It doesn't have any points or anything, but Pardeep, you can just scan this QR using your mobile phone and you can join the test. It's like a fun game. You will get points on basis of how you are answering. Whether you answer right or wrong doesn't matter because it doesn't have any score and I'm not going to evaluate. The only purpose of this thing is to just get the overview of all the processes again so that you can be prepared for your final exam. So you can
Ma'am,
just,
do I need to take the test right now?
yeah, right now. It's a fun test. It doesn't hold any meaning. I can discuss the answers actually.
Okay, let me
You can
scan it.
just scan, yeah, you can just scan the QR code and join the test. It doesn't have any marks, so don't worry. So I think,
Yes, ma'am. Yes.
yes, I can.
Mentimeter.
Yes,
Mentimeter.
Mentimeter.
Okay. Enter your name.
Yeah, you can put any name.
Join quiz. Get ready to play. Uh,
Yes, so मैं इधर से जब question लाऊंगी, like I will press enter and each question will appear in your mobile phone.
right, ma'am.
Okay. So I'm starting. So we have 23 questions. So here is your first question. Infused deposition modeling.
Which
Which
of
of
the
the
following
following
factors
factors most critically influences
critically?
the interlayer adhesion strength, assuming material? It's a misprint, so material
Uh,
and nozzle.
Ma'am, I need to answer within this time period.
Yes, yes.
Okay, so
So
within
you
this
can
time
just
period,
guess the answer. I'll
I will
discuss.
not
No
be
worries.
able to read all the options, but
So
I
it's
answered
like
it.
when a lot of people are here, so you have to read it quickly, and then when you answer the question, you get points based on how fast you answered.
Right.
So, okay, I can discuss about this answer. So, in fused deposition modeling, the following factors most critically influences interlayer adhesion strength, assuming the material and nozzle. So, it's like increasing the extrusion temperature within polymer processing. So, this is the answer because if you read other options, increasing the print speed will not influence the interlayer adhesion strength. If you are interested to increase the strength, then you have to play with the temperature of the polymer processing. This is the most influential parameter. So when you have this type of question, you have to be concerned about the what parameter is having the most influence over the process. So who has joined recently, Suresh? So you can open menti.com in Google and then put this code 4486447, and you will join the test. So it's like a test which doesn't have any marks. We are just discussing the answer of the questions. Okay, I can go. So here you can actually see the marks, how much you get. It's like a competitive exam. We use it for BTech classes.
Right, ma'am.
Yes. So Suresh can join, or you can see the question here as well. This is our second question. So you have to read it quickly and answer whatever you feel.
Infused deposition modeling, the function of a heated build platform is
Platform is
mainly
main.
to uh, heated build platform.
Mhm.
Ma'am, I tried to answer. Okay, it will. It. I need to answer within 30 seconds.
Yes. So it's reduced warping. So it's the function of the heated build platform is to improve the part from the point of view of residual stress. So reduce warping and improve the layer adhesion with the bed. So the first important thing is to adhere the first layer with the bed. So that is why we use the heated build platform.
Okay, okay, ma'am.
Next question.
Mm, The third question: in wet polymerization, the curing of resin takes place due to wet polymerization. The curing of resin takes place due to. मैम आपको आंसर बताना पड़ेगा फिलहाल अदरवाइज आई विल गेट जीरो.
हाँ हाँ, मैं तो बता दूंगी अभी सारा आंसर्स और डिस्कस कर दूंगी क्या है इसका रीजन. बैड फूड. Did you answer?
यस.
Okay, you answered correctly. Good. The curing of resin takes place due to the chemical reaction initiated by light energy. So for wet photopolymerization, we have the monomers of the liquid resin. When the light falls into it, light means the laser light or the UV light. When the light falls onto it, the photopolymerization reaction happens. Photo means light, polymerization means the chain reaction between the monomers to get the polymer. So that is nothing but a chemical reaction. So that
केमिकल
means
रिएक्शन.
curing means chemical reaction initiated by light energy. I get some point based on how fast you answer. Okay, we have another participant. Which of the following is a key limitation of the sheet lamination process compared to other additive manufacturing?
Limitation. I need to answer the limitation of
Yeah,
sheet
limitation
lamination.
of sheet lamination.
Low build speed, poor surface finish, difficulty, dense metallic parts.
So sheet lamination is a process which can only print the wooden part or papers. It can print metal, but it's not very common because the process you saw, right? You are using a laser or a knife to cut the sheets, and then a roller is there to just press the sheets together so that it can be joined. It's like हम रोटी बेल रहे हैं और एक के बाद एक रोटी हमने स्टैक किया और फिर हमने बेलन से उसको बेल दिया, तो दो जो रोटी था वो चिपक गया आपस में. So this is the
Hmm.
overall process layman terms में. तो उस प्रोसेस में क्या है, यू कैन नॉट रियली प्रिंट अ हाई प्रोडक्टिविटी वाला पार्ट which you can use for the real application. You can only print some wooden part or paper sheet out of some paper sheet parts which you can use for showcasing or rapid prototyping, but not a real application. So it's difficult to produce part with fully density Like fully dense metallic parts, it's the biggest limitation you can see. हायर हीट कंज्यूम तो नहीं होगा क्योंकि इसमें ना हीट बहुत ही कम आता है. मतलब if you are using the roller will also not have high heat. So surface finish, low build speed are also okay. I mean they are limitation, but the biggest is it you cannot print fully dense metallic parts compared to other processes. Okay. Next fifth question quickly. I'll read it out. In sheet lamination process, parts are built by, you should answer this at least. Your final exam is coming, I think.
Option B.
Okay, just tick. Yes, so it's the fusing or bonding sheet material layer by layer. Ooh. To get the fastest, who was fastest also. Okay, next question.
Material jetting. Metal powders.
Material jetting is where the liquid droplet of polymers comes with a high resolution. So high surface finish capable of full colored or multi-material. Multi-material I showed in the PPT that from two nozzles, two different polymers was coming. So different nozzles can carry different colored polymers. And I told at the beginning that material jetting can print the highest resolution part actually. So highest surface finish and accuracy. Next question. In a SLS stereolithography, over-curing can lead to, first is curing, then over-curing means you're putting more heat than required. So it's dimensional inaccuracy and loss of detail because when you over-cure it, like overheat it, sometimes you end up with a very, very dense and very hard layer. So if you are printing all on a sudden a very harder layer than other layers, so there will be poor adhesion. It's good, it's right, but it's not the poor adhesion with the build plate. It will be the dimensional inaccuracy will be there because you're over curing, so you are also over curing the previously deposited layers, and loss of detail because you can have a distortion in the part. So that's why dimensional inaccuracy and loss of details. Both wrong. Let's go. Eighth question. In fused deposition, the nozzle diameter mainly affects which of the following characteristics? There is one phenomena that is done by the nozzle itself during printing to get the very smooth layer that is called the bead ironing. So that means the nozzle diameter, the stand-up distance, everything is related to the surface finish and feature resolution. Also, if you decrease the diameter, you will increase the resolution because less diametric material will come out. So both are right. Okay. Ninth question. Which physical mechanism dominates heat transfer in the conduction mold of milk? It's a little bit difficult. So it's conducting the heat powder to powder to get the melting of the powder. So it's the conduction mode of heat transfer. Yes, laser power and scan speed. उसमें से scan speed has the highest influence. Next question. Excessive energy density in LPBF is most likely to cause keyhole porosity. Good. See, you are answering correctly. Which of the following defects is typically associated with low laser power and high scan speed? Low laser power, but high scan speed. Like you're not putting enough energy density which is required to melt. A lack of fusion. Yes, good.
Ratio of laser power to the
So there is a very well-known equation, power by hatch spacing into layer thickness into scan speed. It's the volumetric energy density. Yes, correct. You have read about LPBF more? Seems.
Ma'am, I am trying to answer and remembering all the things within no time actually.
Good, you're answering correctly. Which material property has the strongest influence on absorptivity of laser radiation in LPBF? Absorptivity of the layer of a material. So it's like when your surface is rougher, you have higher absorptivity. When you have an oxide formation, you decrease the absorptivity because it clearly depends on the material itself, not the property of the material. Like every material has a different absorptivity for different wavelength of the laser. And it depends if your roughness is more, your absorptivity increases. During DED, argon, nitrogen mainly prevents two different gases. Okay, there should be a comma. Argon and nitrogen mainly prevents. Okay, so it's mainly oxidation, to prevent any environmental contamination with the bead, with the deposition. Also, it maintains a melt pool shape. It prevents the plasma formation so that the laser plasma or plume cannot go back and hit the lens. Then my lens will be like it will affect the lens quality of the lens will degrade. So it prevents all the things. Also, it maintains the shape of the melt pool. Which parameter has the largest effect on cooling rate of metal additive? Cooling rate is dependent on how much fast you are moving with the scan speed. How much fast you are moving. That much fast, the material will be cooled down. So scan speed also has the highest influence on the part quality in LPBF or DD or any metal additive. Next question.
ये तो मैं बड़ा मतलब if I know then I will able to answer cooling rate.
So हाँ ये थोड़ा सा informative है. So you have to
Hmm.
put like you have to remember it. So it's okay.
Yes.
We can see the answer. बस ये थोड़ा सा like ज़्यादा cooling rate होता है इसमें. Its scan speed is very high, so the cooling rate is also very high. So it's 10 to the power 4 to 10 to the power 6.
और what are the units, ma'am? K by S.
It's Kelvin per second.
Kelvin per second. Heat dissipation. Huh, right. Kelvin per
Sorry.
second. Heat dissipates in this na cooling rate.
Yeah.
Kelvin
Heat
Kelvin is the heat.
dissipates. So heat is first used to melt, and then during solidification, your heat dissipates very quickly because your scan speed is very fast. Like the laser is moving very fast, so heat gradient is very high. So the cooling rate is also very high. So
Very
that's why
good.
this is the cooling.
That is
You can write it down for
12.
your own knowledge. Question.
Which microstructure is most common?
Microstructural features ये भी बता ही देती हूँ. So in LPBF, it's like columnar grains because when you print each layer, your cooling rate is very fast. So you get a very smaller grains. Good, you correctly answered. So your grains are very smaller in size, but as you move up your for each layer printing, your previously deposited 2 3 layers also get remelted. And
Remelted.
when it is remelted, at that time, it doesn't get that sufficient space to dissipate the heat. Because previously, when it was printing the first layer, there was argon or air on top of the layer. So the cooling was fast. But when it's the previously deposited 2 3 layers, they have the built layer on top of them. So they don't have a free space or argon or air to cool down themselves quickly. So that's why their heat dissipation is slow. So they became columnar aligned with the build direction. So that's why it's columnar.
Cool.
Next question.
Residual stress.
So residual stress के लिए not even in DED, in any processes, we use the preheating of the build plate. In EBM, electron beam melting, PBF, powder bed fusion, DED, directed energy deposition, material extrusion, wherever you are using the preheating means to reduce the residual stresses. Here is your 20th question. Staircase effect matlab the layer thickness, if it's high, then the layer will slip off from each other. So it's the staircase effect. Okay, correct answer. 3 questions left. Residual stress in metal additive manufacturing parts are mainly due to. So it's a layer by layer process. Layer by layer, you're putting heat, and you are not getting enough space to dissipate the heat, and also the thermal gradient is high. So it's the layer wise thermal gradients. Think like that. So your things will be easy to answer. Second last question. Which defect is linked to incomplete powder melting and poor overlap between tracks? It can be for DD, it can be for PBF. So it's the lack of fusion of the tracks, the adjacent tracks. They are not fusing properly because maybe their overlap percentage is not good. So that's why they are having porosity in between. So that's why they are having the incomplete powder melting and poor overlap.
Overlapping.
Okay, next and last question.
Recoil pressure.
Recoil pressure. It's the toughest question. I purposefully put it at the last. So when you're melting the powder using laser, there are multiple heat transfer going on. There is Marangoni flow for the viscosity difference for the melted powder and the solidified powder. There is the vaporization of the metal because of the high heat gradient at some portion. So from the vaporization, the recoil pressure comes. The Marangoni flow comes from the viscosity difference in the melt pool. So that's all. So this was all about all the questions. I hope the questions. When is your exam?
Ma'am, on 1st of November.
1st of November. Okay, you have time to study. So you study in between. If you have any doubt, you can contact me via mail. I put all this video of the class and the study material in the Google Drive. So you will get the email of that as well, I think. So you can check from there. If you have any doubt, you can contact me over mail. I respond quickly. Okay.
Note, ma'am. Ma'am, I have this question online question paper.
Okay.
So will it like this, or it will? I need to description type answers. I need to write the description type
Uh,
answers.
Actually, I am not related to the question paper and the exam part. So my
Okay,
duty is
ma'am.
to teach here the doubt clearing session. So I actually do not know how which
No,
type
no
of
issues,
questions
ma'am.
will come.
Actually, ma'am, I am having only two subjects. One is online and another is offline. And
Okay.
offline subject is I am able to understand the offline subject, but in online subject I do not know how to answer these MCQs, or maybe there are some descriptive question paper is maybe possible. Actually, I am doing first year PhD student, and I
Okay.
have passed my BTech in 2005.
Okay.
So that's why I'm trying to understand these concepts in a better manner,
Okay.
actually. And
Okay. Okay. Don't call me
a
ma'am,
long way
please.
back, I have studied a long way back, 20
Yeah.
years
Yeah.
before.
Yeah, I can understand. So I would suggest that I have seen the question of the weekly assignments. So based on that, I can tell you that if you are uh, watching the video, the lecture videos, you'll be able to answer 99% of the questions.
Ma'am,
And you,
I am able to understand and answer assignment questions, right? But I
okay,
do not know ना कि एग्जाम में क्या वो रिटर्न में होगा, रिटर्न में मतलब
अच्छा,
डिस्क्रिप्टिव होगा या एमसीक्यू ही हो जाएंगे सारे
okay.
के सारे.
बट मैं बोलूंगी कि अगर आपने सारे वीडियोस देख लिए एंड यू हैव अ प्रॉपर नोट्स लाइक यू हैव नोटेड डाउन ऑल द इम्पोर्टेंट पॉइंट्स पैराग्राफ एंड कैसे कैसे वो समझा रहे हैं सर कैसे बोल रहे हैं कि इसके रीजन ये चीजें हैं आई डोंट थिंक यू विल हैव मच प्रॉब्लम एंड I actually do not have any idea which type of questions will come. Otherwise, I could have helped you.
हाँ, हमने खाली क्वेश्चन तो मैम किसी भी तरह के आ जाए, मतलब एमसीक्यू हो गए या डिस्क्रिप्टिव होगा, मतलब दे हैव
हाँ
आस्क्ड
वो
मी टू
भी
राइट ए ऑनलाइन एग्जामिनेशन, है ना, तो ऑनलाइन
I don't
एग्जामिनेशन
even
तो.
have contact,
ओके.
so I can't even ask. So that is the thing. You
और
can
मोर.
drop me an email. I can contact. I can contact. Try to contact the question person
राइट मैम.
and try to get back to you. Yeah.
राइट मैम, थैंक यू मैम, आई विल सेंड यू एन ईमेल मैम.
You can send me an email so that if I get any information, I can just let you.
राइट मैम, राइट मैम, ओके. राइट, थैंक यू.
Oh,
थैंक यू.
okay. Okay.
थैंक यू वेरी मच.
Okay. Thank you for attending. I hope you all very best for your exam to you and to all the people who have joined throughout this 12th week of course. Thank you for joining.
थैंक यू मैम.